Everyone, today's presenter Dawit, and I'll be presenting about implementing a safety system using smart control. Here are my table of contents, and let me explain in detail. According to news reports from the last year, from 2023, there have been many numerous cases and traumatic experiences in which people who live in underground houses have passed away, unfortunately, due to flash floods or fires. And we think the main reason is because of a metal window, a metal security window called 방범창 in Korean. So although there were many security windows that were used here, and due to the previous example, it's been proved as unhelpful or probably inconsiderate. So many new designs have been coming up. For instance, the Kwanaku has created a lock and alarm system security window in which the user needs to put a key and open the lock and send the alarm just to escape. But that is the disadvantage. It takes too much time. In a very emergent situation such as an earthquake, tsunami, or fire, how can a person even rationally do that? So knowing that these new designs can still be flaws, our team decided to start this research finding a new security window design. So first, we were very curious about how current engineers thought in this issue. So we did a patent analysis. But all these patents, even though they had an innovative or a sound idea, there was one flaw. It's hard, difficult to escape. They all lacked some kind of automation system as well. So they had ergonomical design mistakes, network mistakes, and connection mistakes that kind of really prevented the escape of those people who were in the sub-basement houses. So we were very confused because they didn't work as well. But through many research, we found a trending topic and the new big deal, the smart home. Smart home is a fusion of various sensors and device control technologies that control the house's mechanisms. And furthermore, we found that in global smart home industry outlook, the trend has been growing up for a 14.5% increase from the last year. And we believe that we should use this smart home because we can connect and use as an automation system. So this is our model. As you can see in the top right, our design is pretty similar to the conventional security window. So meaning it's going to have the same durability and the strength as the original one. However, we tweak just some parts, which are the two parts. The top part in which we will make the upper part go up, and the bottom part to rotate the bars so that it can make space for the user to escape. So let me explain. The conventional security windows are very tight. The top part is very tight. You can't even do anything to get release of it. And our idea is to escape, so we need to let the bars down. In order to do so, we need to either remove, break, or just completely destroy the top part. However, our team's idea was to move the red rectangle part up. So how? We're going to use two parts. Number one is using a detachable attachment on the side, the top part, which is this, so they can move up very easily. And the second way is to use something called the rack and pinion, which is a gear, so that when the motor turns, the pinion turns by the strength of it. And if the rack is surrounded by that pinion, it will move up by the intertwining mechanism of the teeth. So as I've explained, the new attachment will go up by the motor and the rack and pinion. We've also created by using the 3D printers, and if you look at the left animation, the motor and the pinion will turn together with the strength, and because of the teeth intertwining mechanism, the attachment will go up and release from the window. So it's not the entire window, it's only the top part that is. So now that the top part is removed, now the bars are just left there. In order to escape, you either you need to remove it by force, such as pushing or pulling. But our team's idea was to rotate the 3 bars down up to around 90 degrees. So we did this by using bevel gears, which are gears that are perpendicular. So in which, if one gear turns, the perpendicular gear can turn with the same strength as the motor. So if the small bevel gear is attached to the motor, it will rotate the big bevel gear simultaneously, turning the bottom part together. And not only that, to keep everything fixed and stable, we also use a metal bearing in between. So as the first part, we also created a 3D model of it and tried to test it out. On the right side, you see the animation. The motor turns the small bevel gear first with the strength of the motor, and simultaneously turns the big bevel gear, which turns the entire bar and the bottom part together up to over 90 degrees. However, there can be malfunctions as well, and even in dangerous situations like fires or flash floods, the electricity might cut off, or sometimes the controlling system may break down. So we made this manual opening switch, in which there are 2 verification steps. First, you push it straightforwardly, so horizontally, and then push up, so that the top part can manually go up. And because this is a pretty complicated design, the only person inside the house can open it, but people who are trying to break in, the outside cannot. So this is the overview of the creation of our automatic safety window. From the top part, we're going to use the rack and pinion to move up the top part. And from the bottom part, we're going to use bevel gears and the motors to rotate it so that it can come down. And the very main advantage of this design is that it can be reusable. Just by reversing the motors and the rack and pinion, it can go back to its normal state, which means you can reuse it again any single time. Next, we have designed our smartphone to test it together with the security window, together with these sensors and IoT modules that include our phones and Bluetooth modules as well. Here is a summary of the flowchart of the smart system. We are going to take disaster alert data, weather data, and sensor data inside our house to analyze what's going on around and inside our house. Then it will send to the smart home and choose the side to open or close the window. But as I said again, there might be malfunctions or something unexpected, so we're going to use the manual switch or some additional IoT devices like smartphones or laptops to remotely open the window. However, there's another problem here. From the disaster alert, weather data, and all those sensor data, could we even accurately know and detect what's going on around the house? No, not really. So that is why we're going to use something together with artificial intelligence. Let me explain. The first AI is using the weather data and to analyze it. So it's going to detect province-wide natural disasters. So I got this data from the National Weather Data website, and then from there I crawled the data and made it to CSVs into complementary situations like fire, flooding, earthquake, and normal CSV. And using that, I trained the AI using RELU, activation codes, and softmax to train the AI. And after that is trained, I will put an input to test if it's a disaster or not. And lastly, using the KNN algorithm, it's going to test what type of disaster it is as well. The second data is using the danger message data, detecting local natural disasters in a smaller scale. From the KBS danger message data, I think, we will crawl data again, crawl the danger messages and compile it into a danger.csv. And using a BERT model, which is used for strings, we're going to address the type of disaster and the address in the danger message. Next, we're going to use the Harvestheim formula, which involves input, and a magnitude finder to find the distance between my address and the danger message's address and the magnitude of the earthquake. And finally, using some more conditions fire, earthquake, and flooding, we are going to choose to open or close the window. Lastly, AI3 can be used with sensor data. It's pretty similar to the first data because it uses the same model, but it's going to be trained by the sensor data. And overall, this is our smart home system. From the sensors, it's going to give input data into the AI, and from the internet, we're going to get weather and messages data to train the AI together. And if the AI is trained by the situation that's going on, it's going to open or close that security window or not. However, again, as I emphasized again for the third time, there might be malfunctions or something unexpected. That's why we use the manual operating switch or new IoT devices like phones, laptops to open the window or close. So in conclusion, our research result has created a new insight that is overcoming the problems of the patents in the previous past research papers. We have used the rack and pinion design for the upper part, and the bevel gears for the bottom part to work with automation. And lastly, we used AI together with the smart home system to accurately detect what's going on. And this was it for our research result. Thank you so much.